my name's Wayne. I'm a software engineer at Red Badger. I'll be your host for this evening. So for those of you who don't know, Red Badger is a digital consultancy. So we work closely with our clients to create some awesome user-centered products. We also host this event. If you're interested to find out a little bit more about what we do and how we do things, please feel free to have a look at our website at red-badger.com. We have some great talks for you tonight. We're going to kick things off with Chris from The Times, and he's going to talk to us about the React testing library. Then we're going to follow that up with Niall from News, and he's going to tell us all what's up with CSS in JS. Then we're going to have a little break, and then we're going to end things with Lucas from Converge, and he's going to talk to us about tests, types, and why flat earthers are bad at QA. Please welcome Chris to the stage.
Hello, everyone. Hope you all survived the heat today. It's not been too bad, worked at home, whatever it is. My name is Chris. I work here at The Times. We're based in this building. You might know The Times. We're 239 years old or something like that, which is very old. We publish news in a newspaper every day, and we also publish it on our website and in our apps. And that process has lots of steps. Many of those steps involve tooling for our newsroom or developing the app for our readers and various things in between. And many of those things require React, and many of those things need to be tested, pretty much all of them. So I'm going to talk a little bit about how I've done some testing, and I will take you through a React testing library. Now, if you've used React testing library, this might be quite familiar. So please pretend you haven't. If you haven't, hopefully this is useful. I love React testing library. It's great. And just before I kick off, I'm on Twitter at Chris Hutchinson and on GitHub at the same handle. The talk, the slides, the code, everything you see today is up there. So if you do want to look at it afterwards or you miss something, there's lots of code examples in this. Don't worry about looking at them all. If you forget them, it doesn't matter. They're all up later, should you want to have a look at them. So I'm going to get started. I've actually been at The Times for 5 years working in the newsroom on interactive projects for our readers and tooling. And so in that time, we didn't use React. I used Angular for a bit, and then now we use React. And for a long time, editorial interactives go out very quickly. Often they are very tied to the news agenda. So we might wake up on a Tuesday morning, and by Tuesday evening, we've got to have an interactive component live as part of one of our articles that we didn't even know we would need on Tuesday morning, which is quite a challenge. And to make sure that we do that in a way that we can then support it for the next week or the next month or potentially the next year to reuse that, often quite challenging. So we want to make sure we write our tests in a way that's useful. All of that applies to our big enterprise software as well, so our CMS and our apps and our website. So this is why testing React is important for me. And so there's loads of stuff available. Enzyme, you might have heard of. That's a very popular one. React Test Utils, that's the basic stuff that comes out of React itself, that's shipped by Facebook. Cypress you might have used for just general DOM testing. It's pretty good. But I'm going to talk about React Testing Library because I think it's great. And I think it has one thing or a few things that all the others don't do very well or do, but kind of not as nicely. So this is pretty much taken word for word, bar a couple of amendments, because we like to change things a little bit, from the React Testing Library website, which talks about why React Testing Library is different and why you might want to use it. So the way they describe it is it provides you some very simple functions, not too many, not too complicated of an API, that encourages better testing practices. It's about writing tests that are easy to read, easy to consume, easy to maintain, and that don't get you stuck in a hole when you want to refactor your components. You want to change the way it works under the hood. If it roughly has the same input or output, your test probably don't need to change. With Enzyme and other testing libraries, it's very easy to get stuck in a situation where you're testing the internal logic. You're looking at state values, or you're interrogating the specifics of how it works internally. Whereas what React Testing Library encourages you to do is look, as the last line says, at how the software is used and how the consumer of that will experience it. So I fill in a form, it validates incorrectly, I get an error. So I'm going to test those steps, not really worrying about the internals of what the state tree is at that point or anything different. So it's about the way in which you write the test, and they give you API methods to make that really easy. So we're going to start really simple with demo number 1, is really easy. It's a component, it's a div, it renders hello world. This is great. I think if we've all written React, hopefully that is familiar. If you haven't written React, this renders a div with hello world in it. It's pretty straightforward. We're going to import React testing library. There's a function in there called render, which you might guess renders your component. And then in our test, we call render, we pass the component in, and it gives us various functions. And today we're going to look at getByText to start with. So getByText is a way of looking at your component using a piece of text to analyze what's in the component tree. And then I call getByText hello world. Nice and simple. That line throws an error if it fails, so I don't even have to wrap it in an expect call. If you're not familiar with testing at all, usually in testing you wrap your calls in expect the thing to do some other thing, or to be some other thing. In this case, we don't even have to do that because it just throws anyway. So if the text hello world wasn't found, it would just throw and the test would fail. So let's see what happens when, so that was me, I'll just skip through this. Let's see what happens when I run it. Nice, it passes, that's great. Awesome, no surprises there, that's probably what we expected. So let's develop the component a little bit further. Let's try and make it a little bit more complicated. I've turned that div into a form, and now it's got a text input with a placeholder that says location. I don't know what we're doing yet, maybe we're asking the user for their location. So here's my test, and I've done the same render line here, but now instead of getting getByText, I'm using their method getByPlaceholderText. So it doesn't matter what DOM element you use. It could be a text, it could be a search input box. I don't really care. My test doesn't care either. It's just looking for the thing with a placeholder of location. That allows you to refactor your UI potentially in the future. Your test will still work, which is great. So here, getByPlaceholderText location, just like before, it's going to run. And nice, it passes. This is great. Next, on top of using text and using placeholder text, you can also use roles. And if you're trying to make accessible UIs that are available to every one of your users, then you might consider using roles as a way of doing that because it describes your DOM really well. And it says exactly what your elements are there to do. Conveniently, in React, if you use a button, you get a role of button, and that all is wired up. So we've added a button that says use your current location, and at some point, maybe you click that, and it's going to go and do some logic to use your current location. So here's the test, but instead of calling getByPlaceholderText, this is a new test. We're calling getByRole, and this just verifies that there is a button. I'm not doing anything else. I'm just verifying that a button has appeared. And again, I could also use, if I had another element that had role equals button on it, that would work too. And again, we're going to run that. Nice. Still working. Okay, we're doing well. Okay, things have got a little bit more complicated. If you haven't used hooks, this may look a bit unfamiliar to you, but all we're doing here is we've got react.useState, which is just the same as setting this.state if you've used class components before. And so we've got some loading state there, which is a Boolean whether it is or isn't loading, nice and simple. And I've also added a line, so this is our state. We've got a nice handler here which handles the click. So when you click the button, it's going to set is loading as true because that's now loading. We haven't yet worried about the next piece of logic yet, but it is loading. And also we've dynamically set the text on the button to change. So if in a loading state, it's going to say loading instead of saying use your current location. So onto the test, nice and simple. Keep the getByRole line right at the top. We've added this new line called fire event. And this is the next piece that comes out of React testing library, is this nice event firer. And so I can fire a click event and just pass in getByRole button, which is a reference to my button element. And it's going to click on the button, which is great. And then a bit of an extended test case here, an assertion. So I'm expecting that the role, the button, and its text content, which is a nice property you get to say what is the text in this element, is going to equal loading. Nice and simple. If I hadn't put fire event there, that would fail because by default it wouldn't say loading. I put fire event in, a test is going to work. At least I hope so. Let's find out. Nice. Great. Firing events number 2. What I'm doing here is, so I'm going to refactor that a little bit. So before I was using a Boolean flag, yes or no, it is or isn't loading. But what if the load fails? Or what if I haven't triggered the load yet? And what's the distinction between not triggering it and a successful trigger? Like, how do I identify all of these? So instead, we're going to introduce strings to identify our loading status instead. So we've got none, which means nothing's happened yet. And now I've added one here that says pending, which means it's loading. That's sort of the I'm loading state that we had earlier. Refactored that. This is pretty much the same. The text just is based on the value, whether it's pending or not. Test hasn't changed. This is exactly the same test as before. Passed, hopefully. There we go. It passes. And this is the importance of that ability to refactor. We can refactor that implementation. We can grow our tests. We can change them. We can grow the way our components work, but the tests often don't have to change. They may have to, depending on what you're changing. But in most cases, we're not worrying about the specific implementation. If I had been checking if the state value was a Boolean, then all of a sudden my test wouldn't work because now it's something different altogether. And so this is sort of some of the power that it starts to give us. And the way in which we're testing is very much, we're not using classes, you know. So if you want to change your class names, that's a really annoying way to test because you have to use those to target. Instead, we're looking at the things that define what makes up our element. If that button turns into something else, as long as it's got a role of button, my test is still going to work. This is getting a lot longer now. Okay, so I've added a new error line to my component, which checks whether the location that's been typed into that input box is valid. I don't really care what that function does. It's not really relevant. But all that matters here is that if the location is not valid, it's going to show an error that says the location is not valid. We don't need to worry too much today about how that works. Let's just assume it does. I've got an onChange handler on that input so that when I type in, it's going to fire some logic. And I now have my test. So much like before, I've got get by placeholder text. This allows me to get that location input. And I've grabbed a new function called get by text, which I'm going to use to assert whether that error shows up, which we talked about earlier. So here I've got a fire event again. And it's, instead of a click event, it's a change event, which is exactly what a user would do when they type into a box. And I'll come back to this in a minute, because there are other ways of doing this, but this is a really good way to start. Pass in the location placeholder element, nice and easy, and then a usual event structure, which has a target and a value, which is just the JavaScript way of defining a change event. Again, I'll come back to that in a minute. I've passed in something invalid. Assume the test knows what invalid. When I write it, I know what invalid is. Invalid in my case is that it's not a postcode. Invalid value is not a valid postcode. So change my event. I've got my get by text. You can use a regex here, so I don't really care what the error message is. Maybe I just want to know it starts with error because it doesn't really matter to me. So I can use a regex to just match on that, which is really nice. Don't have to pass the exact string in, which means if my product owner or my UI designer says, hey, can we change the error message? I still want it to say error, but change the other bit. Nice and easy. Test still passes. At least I hope it does. Yeah, it does. That's great. Next, all right, async requests. Let's get a little bit more complicated. We were doing lots of synchronous stuff before. That was easy. Or at least it felt easy. I hope it felt easy to you. Async requests, we're going to be a little more complicated. I'm now going to actually handle that click and call this, again, arbitrary function, get current location. I don't know what that does, but it's asynchronous. I'm calling async await on it. If you've not used async await, it's exactly the same as promises. It's a bit like callbacks as well, where you've got that asynchronous behavior. So I'm getting a current location from somewhere, and then I'm setting that to my state. And in my test, doing exactly the same thing I was doing before, but this is now when you click that get my current location button, rendered my component, clicking on the button, and getting a display value, which is basically me saying, expect to see an element that contains SE19GF, which is the postcode for this building. And obviously, you wouldn't actually do it based on the geographic place that your server is running, but this is for the purposes of the demo. So I'm going to run this, and fingers crossed, it's going to pass. Damn, I got that wrong. Let's find out why. So the reason that that failed was because that call is to get current location from here, which I'll jump back to quickly. Here is asynchronous. So at the moment that I click on that button and then expect the assertion, that hasn't returned yet. I haven't actually got my location yet, right? I have to wait for that to happen. Now, in other testing libraries, that can be kind of painful. You might have to do a bunch of mocking, or there's various different ways you can do that. That's fine, but it's not always the most attractive thing, and it can make tests very messy. And really, all you care about as a UI tester is, after all the things that need to happen, does my text appear that I want to see? And that's exactly what we get with React Testing Library. So first thing, I've turned my test into an asynchronous test, which means I can do asynchronous actions myself. And then I add this line, which is a little bit repetitive because it says await wait. Basically, wait is a function that comes out of React Testing Library. It's a little helper function for you to just make things easier when you want to wait for other things to have happened. In my case, my promise to resolve. I think the implementation under the hub is probably just waiting for the stack to clear or something of that nature. So it's just going to wait for those promises to resolve, and then I call my just get display value as before, and that one passes, which is awesome. I don't really need to care how that function works. It just does. You might well be mocking that function, like get location, because you probably don't want to actually get the user's location at the point the test is running. But that can be done outside of this very specific test case, and you don't have to worry about that implementation detail at the point you write your test case. This also makes it really easy to go from that non-asynchronous option to an asynchronous one, because you're just adding 2 bits of code, which makes things really easy to refactor. So we know this one passes. This is great. I talked about mocking. We're going to do a little bit of mocking here. So I've taken that component a little bit further, and it now takes an onSubmit prop. So that form where we ask the user for their location, they can provide it using their current location. There's now a submit button. And on that submit button, we want to know what's happening in that. Now this is, if you've written jest tests before, or honestly tested in almost any JavaScript framework, this will be super familiar with you. This isn't really specific to React testing library, but it's good to see the demo. So we've got our onSubmit prop at the top, which takes a function. And then onSubmit, I'm just going to call that prop and pass the location in. Nice and simple. Again, if you've not used hooks, this might look a bit funky. It's just a way of writing my callback so that React doesn't generate it a million times. Don't worry too much about the detail. And then here on the form, I've got my onSubmit handler. Nice and easy, that's calling this. And then I've added a button, a type of submit. And I'm using this test ID, which you might be familiar with from other frameworks. This is a first-class citizen in React testing library. Makes it super easy to target stuff if any of the other options you get given aren't great. I think in this case, there's probably plenty of other options. You could do something using the display value of the button. But for now, I'm just using a test ID as a demonstration. And so in my test, I've mocked my submit prop. And here, so before, you might remember I passed that change event where I had to do a change, and I passed a target, and then a value as this sort of slightly unpleasant object. It didn't look lovely. Thankfully, React Testing Library has a solution to this. An associated library called user event, which comes from the same people that make React Testing Library, generate these, which are little helper functions for doing human-like events. So user event.type, it's basically the same change event that I was doing before, but it's just wrapped up in a slightly nicer API. And user event.click, again, it's the same as me doing the fire event.click that I was doing earlier, but it's just a slightly nicer API. What's really lovely about this is that they are looking to grow the number of user events that you can do and also give you options. So for example, user event.type actually takes a third argument where I can pass into it how fast I want the user to type, or whether I want to do a few characters, wait, do a few more, or whether I want to backspace during it, which may all be very specific cases. If you think about something like a live search, you might well want to handle things as characters are going in differently. And so being able to test that in a really easy way is really hard, or not super hard, but maybe your test code is going to be really messy if you try and do that with manual event firing. But with this, it's one line of code, and it's super easy to do. So I would definitely recommend user event if you are looking at this. And then at the end here, I've got my expect to have been called, and I expect my postcode to come out nice and easy. That is a mock, nothing fancy, definitely passes, nice and easy. And so you can see here we're sort of building up a full component. I mean, if I go back to that component now, these tests, pretty much all of these tests still run. If I went back to all the other ones and I went to this newer, fuller component, all of the previous tests you've seen, bar the first one, would run successfully. So that's nice. It makes it easy to refactor, and your tests are nice and stable. This is easy, and it makes it easier to read as well. So this is good. So one final demo, which I really love, and I borrowed this off Twitter. Someone sort of posted this as an idea, and they sort of thought this would be cool. I can't remember who that was. I will remember. And so this is, if you ever use React Router, so if you want to navigate around your application, you might define something that looks a bit like this. So I'm saying when anyone visits the /root, they're going to get the index component. And when anyone visits the form root, they're going to get our nice location form that we've been building up for the past few minutes. This is in my application code. I can export that. And now inside my tests, I've written a little helper function called visit. And if you use Cypress or any kind of integration testing library or something like that, you might well have written or used a function similar to visit, which is saying if a user visits this root, something happens. Often that's restricted to the realm of a real browser. But with React Testing Library, we can implement what in React router, they give us a memory router, which is just an in-memory router. It doesn't really have any persistence. It's just for the lifetime of this function call. And so I've made a router, given it a path, which comes in at the top, and then I render out my whole tree, passing those roots in the middle. And so in my test, all I call is visit form, which is really lovely. It's just, if I was a user, I'm going to go to the form route. And hey, I can also use snapshots. If you used Jest snapshots before, it's going to generate a whole DOM tree of what that page looks like right at that moment, which again, in 2 lines of code plus a little helper, is a really lovely way of doing that, nice and clean, nice and easy, and just gives you that confidence around what that's going to do. And again, you're not messing around in your test case about how you get to the root form and how that mounts on the DOM, and you don't have to worry about all that. Just call visit, pass the path, nice and easy. If you passed a path that wasn't valid, you get your 404 root. So this stuff I really love, and fingers crossed this passes. Nice. Okay, so that's all the demos. Lots of stuff there. Loads of stuff I haven't covered, which I think I've listed a few here because they're trying to preempt questions. I know we have a session for questions anyway. So if you do server-side rendering, you might want to hydrate your page. And React Testing Library gives you the ability to test hydration out of the box. So as well as having a render prop, you can also pass in an existing DOM tree, and you can test the result of that. I've done plenty of testing on server-side rendering plus hydration, and it never quite works how I expect. This has made that much easier to guarantee. What's important with all of this is done in JS DOM. It's done on your in Node. It doesn't use a browser, which means although these, when this is kind of a joke where it says 33 milliseconds at the end. That's a random number generator, right? Which may as well be how Jest works. I don't know, but they're super fast. I can write 100 of these, and I can probably do them in less than a few seconds. And that's great, and Cypress and other tools have a place because they're in real browsers, and you can assert things in a much more confident way about how it will actually work in say, Chrome. But what's nice about this is it's super fast, and you can do it pretty much on any machine, anywhere, really quickly. So that's server-side rendering hydration. Really lovely little feature. Makes things easier when you are dealing with that barrier between a server render and a hydration. Unmounting behavior. What if you want to make an analytics call when you unmount your component? Or what if you want to clean up event handlers? Really easy to test. React Testing Library gives you an unmount function. You just call unmount and then do whatever assertion you want. You can guarantee things are done in 1 line of code, which is really lovely. Prop changes. Maybe you've got a component that takes some props and it renders once and then the props change and you want to see that it re-renders. If you've done a classic class component and you've used component did mount and you haven't done a component will update, you've probably stumbled into this issue before. And so this is a really easy way for you to say, okay, I've rendered it and now I'm going to re-render the same thing but with different props. I want to assert that the right thing happens. Really, really, really easy to test. Again, 1 or 2 lines of code. Custom hooks. If you are into hooks, which you should be, they're great, then you can write custom hooks and you can test them. This is an extra library that comes out of testing library called React Hooks, and it's really simple, and it's pretty much the exact same API that you've seen with a few additions for hook-specific stuff. I maintain a couple of my own personal hooks for stuff I do, and this has made it so easy to test those. Particularly when testing hooks is a bit weird because it's not like normal JavaScript and things don't, not like normal React. They don't quite work how you might expect. So that makes things really easy and a really lovely API there. Works really well with the React testing library as well if you have that. And then finally, I've already mentioned human-like events. Things like typing and clicking. And they have a few more. Double-click is one they support, so if you need to handle double-clicks. Again, firing 2-click events in quick succession in your code is kind of crappy. But firing just user event.doubleclick, really lovely. Makes your code really clear, makes your test really clear about how that works. And not forgetting, because this is the most important one, is that there's a React Native version of this as well, with almost the exact same API. So if you're writing React Native code, you can use the exact same API, almost all the functions I've already described today, to test your React Native code as well, which again, is really nice and makes things, you get all the benefits that I've already talked about. So one final test, do I get to the end of the talk? I do. Which is great. 24 milliseconds as well. So as I said, all these slides, working tests, documentation links are all at this link very shortly. It's currently a private repo. It won't be very soon. So that if you want to get to me, just search Chris Hutchinson, Twitter, or Chris Hutchinson, Google, GitHub, or go to the React London Meetup page. Everything's on there as well. And yeah, go out and test your components. It's really awesome. Thank you very much.
Thank you very much, Chris. Any questions? If that's, just raise your hand. Tiff will come and give you a mic at the back. I think you were first.
So does React Testing Library help with enforcing TDD practices? You find?
I mean, I think it can do, definitely. I think, it's a tool. It has to be used in the right way. For me, the thing it's better at enforcing is that you're testing the way your components are used. You can abuse that for sure, and if you're not following those practices, you may not do so. But if you've got a really clear idea that you're going to have a button and an input and a placeholder, you can totally write those tests up front and then program your component afterwards. And so I think if that's the mindset you want to work in, it can definitely work for you. And because it has the ability to be very vague, as you saw where I was using like roll button. That's really vague. I don't know what my button's going to be yet, but it's a thing with a roll of button. Then that's really good when you haven't yet decided quite how you want to implement your component. And if you know that, okay, I'm going to type in the box and I'm going to put something invalid in and I want a message, again, these are all requirements you're probably going to get before you start writing your component. So yeah, you can totally do it this way. And then probably as long as you're picking things like semantic HTML, which is a really important part of this, you have to make sure you're not just writing divs everywhere. Use things properly, use accessibility properties well, then this is going to be a lot easier. So I think it definitely can help, but it does really need the person to engage in that right at the beginning.
Any other questions?
How would you test, let's say if you have a component that relies on the store, Redux store?
Yeah, okay. So the example where I had the router, so you can render your component, let's say it's just a simple component. You could render it around, you wrap whatever you want up around it. So you might choose to wrap it up in your store. I've not actively used Redux with this library, but I have used React Context, which kind of has sort of similar parallels, right?
It's basically, you have a provider somewhere.
Yeah, so in React Context world, often I put my provider around it. I usually turn that into a helper function, like I did with visit, just to make that simpler in my individual test cases. And if I need to change that, it's easy to do. But at that point, you've kind of got the freedom of whatever you need to do. Usually I'm passing in mock data or some kind of existing state tree or whatever it might be. But at that point, you're really at the realm of whatever you want React to do. But when you call render, so when you eventually call React Testing Library's render function, it is just calling React DOM.render under the hood into a JS DOM tree. So at that point, you're basically in what your real application is doing. And you aren't in that weird world where maybe an enzyme where you're doing shallow mounting and you're going to get only part of the tree or weird things like that. It is pretty much a direct representation of what you get in the DOM, which makes it really easy to test, because that's pretty much how you would test when you're deving and you're using a browser. So definitely can be done. I've done it with context, and you just wrap up your render call with the other bits that you need.
Yeah, what I did was, I just had this problem today.
Okay.
And I created a component that would export like a render with Redux, and it will take a state object. I'll just pass whatever state I needed with mock stuff.
Yeah, and that should work here if you do that sort of similar approach.
Cool.
Nice.
I'm working with a small startup for 3 months. What we're using there is Jasmine, TypeScript, and they are talking about using React as a test framework as well. What would your advice be about the differences between using, say, TypeScript versus Jasmine versus React at that initial stage of starting your career?
So I'm thinking about when I learned testing and tried to learn following that TDD principle. And I remember it being quite challenging for me because I'd come from I would smash components out or pages out and it would just roughly work and I'd kind of move on. And so moving to that environment was quite a challenge for me. This is kind of why I structured the talk in this way. Start simple, write a hello world component, in plain JavaScript if that works for you, and grab your testing framework, start with a very basic file, and just try and get that green pass tick, because that's so satisfying. And just do it one step at a time, one test at a time. And as I've done, I built up a component, I added a feature. You might choose to do it TDD, you might choose not to. But just slowly building it up is, for me, really worked well. And having someone else around to ask questions and to quiz. When I was doing this, there was a colleague of mine who was at a very similar level to me, who neither of us had really done testing before, and so we sort of did it together. That really worked well. Maybe not everyone's in that position, which is fair enough, but that did help me. And the events like this hopefully can help people here. I'm sure if you have questions, happy to help as well. But starting simple is for me the best way, and different tools are going to have different approaches. React Testing Library is actually quite strongly opinioned in terms of how it wants you to do stuff. Unlike a tool like Enzyme, which is a different way of writing tests, it's got its own way of doing things, but pretty much you can do what you want with it. Whereas with this, it's much more structured. That might be helpful, and if you dive into their docs, the documentation for this I really love. It's really well written, and it has really good explanations for why they do things in a particular way, and so that can help as well.
Great. Got time for one more? I think you were first.
So, is there any rationale between their naming of the API calls? Because I noticed they use the fire event instead of dispatch event, and nothing seems like the native API. Yeah,
that is an interesting question. I think fire event is it's just common terminology, I guess. Trigger event or send event, they would have been other words. I don't really know if we have I guess emit event. I don't know what you might have used otherwise in that example.
Why didn't they use the native names of functions? For example, dispatch event is the native one and done.
Got it.
Right, or get by text
Yeah.
instead of inner text. Or
Got it. So I'm guessing they are imagining a world where it's not DOM only. Right, you've got the native implementation where maybe some of these functions, these DOM specific things don't exist. So you've got the difference between what's a JavaScript API and what's a DOM API. I guess maybe that's some of it. Otherwise, don't know, maybe get by text is just more readable in your testing environment. Maybe it's easier to not really care whether or not you're digging into the inner text element, or you want, maybe it's easy to just abstract that away and you just go, I want the text. And you can call what's useful, I think this is possibly the other thing, get by text content, which I think I used in the third or fourth demo, is a really good example. Depending on what you call that on, it's got a different tree of how to get that value. So it keeps your test clean. I don't really have to worry. I just go get by text content. I can pass it a select box, a text input, a DOM, a div, you name it, and it will basically eventually end up at the right bit. In most cases. Of course, if it's not, you can use query selector as normal. One of the exports that I didn't show you is that it gives you an element called container, and container is just a DOM node. So from that point on, you can do query selector all, you can do anything you might otherwise expect. What's nice about this is it's JS DOM under the hood. So everything is just a DOM node. And so if you want to go down that route and that works for you and your test and your team, that's totally an option.
Cool. I'm sorry for those that have other questions, we're going to have to press on. If you have any other questions, obviously, I'm sure Chris will be around.
I'll be around afterwards.
Those, during the break. Cool.
Nice
Thank you very much, Chris. Great. So we're going to crack on with our second talk. So if you please welcome Niall to the stage.
Okay. Hi guys, I'm Niall. I'm a software engineer here at News UK. Recently we started looking into building a design system to be used across the companies here at News UK. And one of the things we looked at building was a component library for this. And one of the things we had to look at is how to actually style, how to share styles, ability to team, all of these kind of things we looked at. So today I want to talk to you about CSS and JS, which I found actually can be quite a contentious topic. Some people fervently believe that CSS should not be inside your JS and should be separated out. So to look at CSS and JS, let's look at where we've actually come from. So in the beginning, we had CSS, and I guess even before this, we would have had inline styling. So because of issues to do with reusing code, and we came along with Sass and BEM and CSS modules to answer things such as naming collisions and reusability. And now we're at CSS and JS, which actually now people also just refer to as style components quite a lot of the time, even though there are other libraries out there. So let's just look at these. So this GIF, I think, sums up CSS quite well. Is you change something and you it just does the unexpected sometimes. So this is because of the scoping issue. Because CSS is set in a global context instead of modularized, when you change something in one area of your application, it can actually cause severe effects on the rest of your application. This also comes with naming collisions, to do with the naming of classes. Also, in my experience, CSS drifts towards bloat. We end up having lots of CSS that's actually wrote over and over again. So unit testing, I don't know. So all of this leads to one thing, and that's frustrated developers. So along came then Sass, which was built up on top of this, to which promotes reuse through variables and mixins and other things. Adds a bit of structure, is flexible, and it comes with helper functions, such as your lighten and dark. However, there are issues still. And one of those issues that are still not solved is the naming collisions. And BEM tries to solve this using a namespacing convention and aims to promote the reuse of your classes. However, it is difficult sometimes to maintain this, and in my experience, at scale, this causes an issue. People forget what they have and end up writing over and over again the same code. Also, it's difficult to render your critical CSS for your render critical path, and you end up loading code onto your page that is not needed. So CSS modules is another thing that came along after that tries to solve this by being modular. It uses atomized naming to solve the naming pollution issue. And this obviously makes it much easier to debug. Because your CSS, your styling, your JavaScript are all modularized in the same place, if there's an issue, you know where it is. However, you do need developers to buy into this, because now you need to start thinking in that modular way instead of actually the global context. So now we're on to CSS and JS, and it's really important to remember here that this is not anything special. This is still CSS at the end of the day. We're not using something new here. So the way it does this is a layer of abstraction over the CSS to generate your CSS using JavaScript. So this solves the naming pollution issue and the scoping challenges, but much in the same way as CSS modules by using autonomous naming. So what is out there? What can we use? What libraries? What is there? And the answer to this is pretty much the answer to a lot of things in JavaScript. There is a lot. You have one thing, you slightly disagree with it, instead of fixing it, let's build it again. And that's pretty much where we are at with this. So obviously, you can't actually look into every single library. You need to actually manage your time. You need to choose these. So today, I'm going to actually go through a couple of these. But first, let's look at how to CSS in JS. How do these actually work, like? So here is my custom library that I built in 20 minutes 2 days ago. And basically, just to show how to do this. So you can see here that we have two objects, one style object and style2 object. Very similar. The difference is in the background color background color inside the objects. And down here, then, we call a function called styled. And into this, we pass an element that we want to render and the style to go with it. Very similar to how a lot of the APIs for these CSS and JS libraries work already. So we can see this is the styled function here. And it does things very, very simply. It takes that object that you passed into it, and from that, it generates a CSS string. After that, it then looks at the class name. It creates a unique name for this. So in this case, it uses a library unique ID, but it could do something like style components, which gets the ID of the component plus the styling and creates a hash from that. You could do it that way. It's just the way I did it. So then it creates a style tag. And with this style tag, it puts inside it that CSS string that you created and attaches it to the head. And therefore, you have your styling with your component, which is then rendered and created. Simple. And you end up with this. So this is obviously not optimized. This was made in a couple of minutes. It was, yeah. And you can see here that you have two style tags with two different class names, two unique class names with their style inside it. And they're attached to the div and paragraph tag at the bottom, rendering out your two different elements with different styling on them that are totally unique to them, causes no scoping issues and no name inclusion here. So let's look at some of those libraries. So obviously, as I mentioned, you can't look at them all because somebody's going to build 10 more next week. So I looked at 4 of them here. I looked at some of the major players. So you're looking at 2 real major players at the moment. This data is accurate as a couple of days ago. And you're looking at style components and emotion. They're 2 of the most popular ones at the moment. There's also other ones like Styletron React, if anyone's familiar with it. It's used inside Uber's base UI design system. And you also have React JSS, which is just another one. So let's look at how these APIs work. How do we actually use these libraries? So here's my example, and it's just 2 buttons, 2 simple buttons, and basically it's passing in a property primary. So inside Emotion, it works by passing in this property. It intercepts this property, and then it decides what style to show based on it. Very similar. Very similarly, we have Styletron. Exactly the same thing again, passing in properties and deciding what style to display based on that. And again, style components, the same thing. React JSS works a small bit different. It's a bit more similar to CSS modules in that you actually get classes. You inject the styles in. It passes in a class's prop. And then you apply that to your individual elements as you want. But the thing to note here is that there is a common theme. A lot of the libraries, and especially the 2 major ones, have really settled on a common API between the 2 of them, which is very important to note if you decide to go from one to the other for other reasons. So one could be that style components is coming out with its version 5, which they also refer affectionately as beast mode soon. So you might decide, oh, I want to be using that. So let's look at style components because it is the most popular one out there. If for any of you keen-eyed observers, you would have seen that it has quite a lot of stars on GitHub. While stars alone aren't a good reason to use it because those stars could have been accumulated in the beginning before other libraries came along, it is still a decent metric to look at things. Also, it has actually quite a lot of forks of it, and there's relatively few open issues with the library. And this is because it has quite a large community backing. There's a lot of people who use this, a lot of people who really like it. It uses atomized naming, just like most CSS and JS libraries, to give you individual naming, like my custom one, which I guess you could, at this point, you would release it, give it a logo, and tell everybody it's lightweight. But yeah, so much like that, same thing. It's feature-rich. There's a lot of things that come with this library that you won't have to build yourself if you use it. It's got VS plugin, because we all have plugins. It comes with nested theming. So I mentioned that we're trying to build a component library here, part of our design system. And this is actually really important for us, because if you think about it, you don't want to write these themes over and over and over again. Because, for example, the Sun, here at News UK, the Sun has sub-brands. One of them is the Sun Racing. Very similar, very slight differences. And basically, you can nest these theme providers, passing in themes, just overriding certain parts of the theme. So you would get your parent, and you would override it. It does this through a shallow merge, basically. It also supports server-side rendering, which is obviously very, very useful these days, and especially for us as because we push a lot of content, and we need it to render fast. So it uses it, because if you think about it, and you think back to my example, it's only rendering the components that are actually used. So what does that mean? It only renders the CSS that's actually used. So the Sun are currently finishing up actually trying to get their critical CSS into individual files so that it's only what is used is loaded on the page. This is really important for performance reasons. And with style components, you don't need to worry about this. Only the CSS you use will be on the page because it is generated by the JavaScript. So only the components that are there will generate CSS. Also, style components, you can unit test it. You can unit test these styles now. Yeah, there is a plugin for Jest that allows the use of this, which is really convenient. It also, like Chris's testing library, it has a flavor for React Native, which is really convenient, really good to share across teams. So, however, there are issues. And this is one of the issues that is an issue with all CSS and JS, is not unique to style components. There is a learning curve. Everybody knows CSS. We learn this in college. We learn this when we get in our jobs. Everybody knows how it works. But with CSS and JS, you now need to learn a different way. And this is something that goes against it. Styles are tightly coupled to your JavaScript. It is, and that's the way it's rendered. And some people think that shouldn't happen, and you should not do this. And it's a valid concern, and it is something you should think about. The next one's probably a bit laughable at a React conference, but it is React-based. And it is something you should consider. If you want to move away from React, you want to use something else, this is React-based. So it is something you need to consider. OK, so I mentioned theming. So theming is a big part of this, and it's really, really important, and it works really well here. So you can see here I've got an object which holds a theme, which basically just has one thing in it at the moment. It's just a color, medium sea green. And you can see here it's passed into a provider. And above here at the top, you can see that what happens is inside this component, you now have access to a prop, which is called theme. And that is your object, and it's passed down. It uses the context API under the hood to actually allow this. So if you put this at the root of your project, every style component below would have access to this theme, which is very convenient instead of having to pass it down through components. I mentioned nested theming, and as it's really important to us, I feel it's probably important to a lot of other people. So you can see here we have 3 themes. Theme 1, Theme 2, and Theme 3. I know this might be a bit hard to see, but Theme 1 basically has 2 things in it, a background color of red and a color of white for the text. And then Theme 2 is passed into the theme provider that is nested inside the original Theme 1 provider. And what happens here is it overrides both of these values. And then lastly, you have Theme 3, which overrides only one of these values, which is the background color, but inherits the actual text color. So you can see here what happens. It renders out 3 different buttons, one of them which is using Theme 1, one is using overriding all of Theme 2, all of Theme 1 to create its own theme, and then Theme 3, which is inheriting the text color but overriding the background color. So I want to finish this on a quote. Actually, this is something one of my colleagues said to me, and I think it ties in nicely here. So at the end of the day, we are all trying to achieve the same thing. We're trying to achieve styling for our applications. So whether you believe that CSS should not actually be wrote in JS, or you believe it should, and you're already using this, remember, it's the direction, it's not the road to focus on. And just remember, and lastly, I'll take any questions that you might have, actually. Any?
Okay, any questions? We've got a few here. Let me just grab your mic.
Hi.
Hello, great talk actually. I have a question for you. If you would like to build a design system that you don't care about the framework that's used, because currently the style components is based on React, do you have any suggestions on how you would build this?
What technologies are you using?
Let's say that we have a team that we have. I work in a company, and there are different teams that they use different frameworks. Like there are teams that they use Angular, there are teams that they use React, there are teams that they use, for example, Aurelia, which means that this company needs a design system, and all the teams should actually work easily without actually having a design system and build these 3 times: components in Aurelia, components in React, components in Angular. Do you have a suggestion for this?
So that's actually interesting, and I actually did look at a lot of design systems, some of them that are cross-platform, like I don't know if you're familiar with Material.io from Google. Some of these work across different technologies, and one of the ways I've seen people doing this is by putting their styles into what is called tokens. These tokens are put into files, like a YAML file, that anyone can read from, and therefore it shares that theme. These tokens represent styling attributes, and as long as you basically map that back to your desired technology, you can share this theme file, which is a YAML file, JSON file, or whatever, across different technologies. As one of the ways I've seen actually people solving this exact issue.
Okay, good. Thank you.
Any other questions?
So my company currently use CSS modules with SAS as well. And I'm currently, because we're using a lot more server-side rendered stuff, where I'm moving over to the idea that CSS and JS would be a good idea for us to start implementing. What would you suggest to kind of begin that process of moving over from using CSS modules to using CSS and JS?
So actually you're at kind of nice points in that if you're already using CSS modules, people are already thinking in that modularized pattern. So that's all, that will help you there. Trying to think. So to move over, so first of all, the first thing you need to do is you need to look at what your company's needs are. So for example, if your company requires that the CSS file is all inside an actual style sheet, so style components does not actually support this, whereas Emotion does. So you need to look at what the actual needs of your company are, how you're rendering your components, and then you need to look at what each of these libraries support and basically make a decision from there on what to use. That's what I would recommend doing, performing a needs analysis and then working from there.
Got time for one more?
I was wondering if you tested among all the other options that you showed us, emotion, style components on, if they have any advantage in terms of performances, or under the hood, if there is anything which optimize, particularly in terms of render and then painting of your document.
Very important question, and yeah, we did actually look at some of these. So I can tell you StyleCharm React actually produces a much smaller bundle sizes. It uses very clever reuse of CSS styling inside their names. I know Style Components is releasing their version 5, which I referred to as beast mode. That's going to reduce, according to them, their actual first paint. It's going to speed it up by 25%. So there are different performance gains between the two of them. So yeah, we did look at actually different ones of them. We decided to go with Style Components because it has a lot of features. There's different ways of actually using Style Components. You don't have to use the API I showed you. They offer different versions, and you also get quite a fast render comparative to the other libraries as well. So you're not really losing that much there. But yeah, there are different bundle sizes between them, and it's actually important to note that. Yeah.
Great. Thank you very much, Niall.
Thank you.
Okay, so we're going to take a quick 10-minute break now. So please feel free to give us, pick up another drink, take some selfies with the lovely view we have, maybe. Toilets are just up across the corridor, just on the left, and I'll see you back here in 10 minutes. Thank you. So that's crack on with our last talk. So if you could welcome Lucas to the stage.
Cool, well, thank you everyone. So I know the title of my talk is quite intriguing. We're going to get there. So my name is Lucas. I maintain a couple open source projects like Chai.js, Sinon.js. Does anyone use any of those? Chai.js, Sinon? Okay, we got a few people. Everyone migrated over to Jest. No worries, I started contributing to that too. So today what I'm going to talk about is tests and types, but in the context of, I guess I'll have to use this, of correctness. So I think we're having technical problems. The clicker's not. Oh, there we go. OK, we're back there. OK, so what role do tests and types play in the testing process, and how we can use one to complement the other? And well, I thought that the best way of actually explaining this was actually through an analogy between physics and mathematics. So let's first talk about physics. And the aspect of physics I would like to focus on especially is the scientific method, right? So what does physics try to do, right? Does physics try to reach truth? Well, physics actually, what it really tries to do is to reduce uncertainty, right? We cannot prove the truth, right? So when someone gets hit by an apple, they cannot prove that all apples are bound to physicists' heads. But they can prove that, well, apples are not bound to physicists' heads, and we can prove what things are not truth. And then eventually reach a truth, like we're going to make a model. We're going to imagine things, right? We're going to create this abstraction of the real world. We're going to do some experiments. We're going to check if they match our model. And then we reduce uncertainty. Every experiment we do gives us more evidence. So just like in physics, every test is an experiment. We predict the outcomes, and we verify whether our expectations match reality. And the good thing about tests is that actually when we're doing tests, right, debugging is a scientific process. Right? We get something wrong, right? Then what we do is, well, we create this theory in your head, you create this model, and you check whether your expectations match reality. But luckily, we can alter that, and then we can make our test pass. So in the same way, the physicists cannot prove that they're right with our experiments. Tests cannot prove that we're right. They can only prove that we're wrong. So here, let's say we have a function which has true tests, right? So we have sin of x plus 1, and we have these true tests on these two places, right? So we give it as input like something around like 1.5, and we get true as a result. But however, we can have another function, right, which hits those same true points for those same true inputs. So actually, these tests do not restrict enough the valid implementations for this function. So they do not guarantee correctness. So with more tests, we can rule out other intersecting implementations, and therefore we can get more certainty. So tests, they cannot prove that we're correct. They can only prove that our code is not correct. And they actually provide evidence, just like experiments do. And a very important thing about doing experiments is that you should be very worried about what you observe, so that you do not observe that which confirms your findings, which is why flat earthers are better at QA, right? Because when they do tests, they do not try to be proven wrong. What they actually try to do is to observe the things that confirms their beliefs, right? And therefore, their observations are biased. So when we observe reality and we see which evidences match or do not match our expectations, we need to be very careful on what we choose to observe. Because in the same way that experiments depend on observation, tests depend on assertions. And observations, like many people think, oh, science is not really biased. But actually, what you choose to observe is a very important thing. It's not that science is biased because of the projects we choose to fund or not to fund, but also because of the things we choose to observe. As Karl Popper once said, he noticed that observation is always selective. It needs a chosen object, a definite task, an interest, a point of view, and a problem. It presupposes similarity, classification, which in turn presupposes interests, points of views, and problems. Right, so we must be very careful to not try to confirm our beliefs, but actually try to be proven wrong. And this also shows that code coverage doesn't really matter if you're not observing what really matters. If you don't have expectations, if you don't have really assertions in the right place, and you're not trying to prove yourself wrong, if you're designing your tests just for them to pass, if you're trying to get the green bar fever, well, then you're being biased. So James O'Coplin said this, and I completely agree with it, is that you cannot have 100% coverage. So he defines 100% coverage as having examined all possible combinations of all possible paths through all methods of a class, having reproduced every possible configuration of data bits accessible to those methods, and every machine language instruction along the paths of execution. Anything else is a heuristic about which no formal claim of correctness can be made. So if you have this function, right, you absolutely cannot go through every single point. You cannot guarantee that you're going to be right. You cannot simply test everything. What you need to do is you need to constrain your implementation enough so that you can have evidence enough to prove you're correct. It's not that gravitation theory is wrong. It's just because Newton didn't have the test cases he needed to say, oh, maybe we need this other theory. So that's something we cannot do if we have a universe with so many points to test to go through. And that's very different from mathematics. And maybe now you might be mad at me because I'm going to say that mathematics is not really a science. So if you are, just tweet at me. It's going to be fine. And that's because in mathematics, we can actually reach the truth, right? We can attain the truth. So when a mathematician has an idea, like our friend Pythagoras, he comes up with a conjecture. So he thinks this thing is true, right? It's not actually proven to be true. Then he actually goes there and he creates a proof. He uses the rules and the axioms of mathematics, and then he uses this beautiful thing called Euclidean geometry, and he gets a proof, right? He follows all those rules, and he can prove that his conjecture is truth. It's now a theorem, right? So it's now proved, use rigorous mathematical reasonings, right? So within this formal system, right, within these sets of rules, which are very well defined, everything's right. Until some guys come up with no Euclidean geometry, but that's fine. He's right. So we can say that he reached truth. And as Richard Feynman said, mathematics is not a science from our point of view because the test of its validity is not an experiment. You don't have to do experiments to confirm that something's true. And in a certain way, like Atos said also that all mathematical proofs are in a certain sense tautological because you're kind of just like getting these very simple things and you're just building up with them to build proofs, which is like building upon things that you already know are right, which is playing within the rules. And tests are very similar to that, because types are very similar to that, because types have well-defined rules, right? We have this very formal system, which has clear and well-defined rules, which we can use to verify whether our code conforms or not to those rules. Now, whether our code is correct or not, that's another matter. But we can indeed verify statically whether we conform to those rules or not, just like in mathematics. And that's due to the power of abstraction. So abstraction is just the ability of concentrating the essential aspects of a certain context. So we remove absolutely all unnecessary detail, right? So when instead of going from particular inputs to particular outputs, right, which for example, we might have many in the universe where we go from string to integers, right? That there's many valid implementations which can go from string to integer. But if we zoom out, right, if we abstract all that's not necessary, if we go from type A to type B, and we constrain enough type A and type B so that we can then just observe what things morph into, we can just reach the end of road for abstraction. Then we can have a bit of more complex rules and we can reason about our programs and make claims about them which are provable, right? So within those rules, within that abstraction, we can prove that things are actually truth. We can reach truth. We can reach certainty differently from tests where you have to give them this input and check for this expected output in the world of many possibilities. So if you can do this, if you can constrain enough your types, you can actually make it a lot easier for you to reason about your programs. And this is kind of like the essence of computability, right? We get those things, like we get those very unique things we abstract away, and we create those symbols, and we have very clear rules for manipulating those symbols. And this is in a certain way Leibniz dreams. So what Leibniz wanted was to actually be able to compute things. So he wanted that if controversies were to rise, there would be no need of disputation between philosophers than between two calculators. For it would suffice for them to take their pencils in their hands and sit down at abacus and say to each other, and if they so wish, also to a friend called to help, calculemus, which means let us calculate. So what he wanted was for people to be able to use logic to reach the solution for problems, right? We wanted this very specific rules, this set of rules with which he could reach the truth. So getting now a bit less philosophical, types go much beyond just exhaustive checks or checking properties are correct. Also because like all languages are typed, right? The only difference is whether you can check things before they run or let them explode. Like in JavaScript, right? When you get one of those errors, which are, by the way, type errors, when you cannot read a property full of undefined, or when you try to call something that's undefined, well, it just explodes in your face, and basically you could have known that before, right? So languages are typed. The only difference is when you get the errors. So basically you can leverage correctness with types by doing many things, right? So it goes much beyond enumerating possibilities, possible types for warnings in React, for example. You can use types to leverage things like data monad, there may be monad. So basically this makes it much easier for you to handle errors. So basically makes it much more declarative and makes it much more easy to reason about your code. It goes much beyond having exhaustive checks in Redux. I don't know if this font size is good enough, but basically what I'm doing here is having an appended action function which takes a value which should never get there. So basically I can ensure that all my actions are caught, all my actions are handled. And well, we never handle something that we don't capture in the switch case. But I think the most interesting thing, and that's most closely related to what I've just talked, is making impossible states impossible. So this is a theme of many talks already, and it's kind of a known concept in certain circles. And what it's about is mostly constraining your state so they cannot be invalid. So instead of trying to prove things wrong with your test, instead of trying to get those points out of the curve, you actually try to make them impossible, right? Impossible is better than catching them when they run with tests. So I thought about doing an example of this, and I chose blackjack for that. Not because I'm good at blackjack, but it's because it's the only card game I know because of this very bad movie I've watched when I was 15. So I basically Googled a bit just to make sure I would not be writing anything wrong. So basically, making impossible states impossible is about constraining your states in such a way that they cannot even get to be wrong, right? So for example, if you have a type player, right, which has a few information like the country code, a phone, and an email, all those are contact informations, there's a few problems with that if those are optional, right? So if we want a player to always have a contact, with these types, we can have a country code without a phone, and vice versa. We can have none of those properties, and we can have a player which only has a name, for example. So one of the things we can do is create a type for phone and make sure that it includes the country code and the phone, and that both are going to be mandatory. But we still don't need a contact. Another thing we can do is wrap all of those in a contact, right? Create a union type and make sure that contact needs to be a contact. And now we always need to choose between an email and a phone. And if we choose a phone, we're going to be sure that country code and phone are required. So next, we need to know which cards each player has, right? So in this case, our cards are an array of numbers, which represent the value of each card. And the problem with this is that, for example, we can have invalid cards, right? We can have 0, we can have negative numbers, we can have huge numbers. So you can do this ugly thing, which I think people at TypeScript are working to fix. So they want to put ranges in language so that you don't have to enumerate each one of the possibilities anymore. So now we can only have valid cards. We cannot have 0, we cannot have -2. So we're constraining our state, so we don't have to test for those possibilities anymore, because they're not even possible. Then, now, everything's correct. We can have 1, we can have 0, we can have negative numbers. But we can still only have one card. And if Google was correct and told me the truth, I think every player in blackjack must have at least 2 cards, right? So what I can do here is create a type hand, right, which is basically something that contains 2 or more cards. So what I do there is I create an intersection type, right? And it must have 0 and 1, and it must be an intersection with an array, right? So those 2 first must be defined, and now I cannot have a single item anymore in my cards. So I also don't have to test for the possibility. It's one more state I eliminated just by using types. Now for the game state, let's say I have a current state which indicates if the game is still running, if someone won, if there's a tie, or what's happening. There's many problems with doing it this way, right? So first of all, we can have 0 players. We can have a win state with an X player. We can have a running state with a winner. We can have a tie with no players. We don't constrain this enough. So many wrong states are going to be possible, and we need to test for those wrong states. We need to make sure that our code is not going to get there. So what we can do here is that we can constrain our state. So we can have a type win, right, which has a name and has a winner. We can have a type tie, which has 2 or more players that are in a tie. We can have an unfinished state, which has an X player. And then our game state is basically a union of all those types. So now if we do that, we still can have an X player which has busted or surrender if the game is unfinished. So we can constrain that too. So you don't have to write tests for those things because the compiler can tell us, ahead of the time whether we have a mistake or not, whether it's possible for us to get to a state which should not be correct. So now what we can do is we can have a bunch of types which indicate if the player is in a non-play state or in a playing state. And we can have a player state which takes a state T. And now our player is mandatorily going to have one of those states. And he can be in a playing state or in a non-playing state. And now we can use those to indicate that our next player in an unfinished state can only be someone that's still in the game. And there are many other rules that I could keep constraining here, but I think that's going to be for another time. Otherwise, I would be just writing types for a very, very long time. And this goes much beyond type checking. We can also statically enforce, for example, like Rust does, that we're going to have safe concurrency with the borrow checker. But what about tests? Well, for tests, it's very important to know how to test and what to test. So basically, you can use types indeed to do whatever you want to, because also TypeScript is string complete. So you can write any programs that were ever written or will ever be written in TypeScript. However, you cannot constrain your states enough that you're not going to need any tests, right? So even though you can reduce the number of tests you need, you cannot completely not do any tests. So you might have seen this before, and I also think this distinction is very, very important. So you might have seen this way, but I prefer explaining them in a different way as if they were all equal. So this makes a separation between the tests that you write more frequently and how often they run, or like the time they take to run. But I think that actually varies a lot from case to case. But I mean, it's a great definition. By all means, you should go and read that post, by the way. Martin Fowler writes quite a lot about those things. He's really good. But, well, talking about each one of those kinds specifically, for end-to-end tests, well, you might have found it very weird that I used Docker there. But actually, one of the things that I really liked when doing end-to-end tests is to spin up entire environments so that I can do proper end-to-end tests. Because, if you have systems which have many services, you actually need to interact with them and establish certain states. Sometimes it might be hard to do with just tools that people provide you to do for doing end-to-end tests. One of the things that I quite like is Selenium. I'm not a big fan of Cypress, even though it's really good. But Puppeteer is also really nice. So basically what they do is they allow you to control browser. So with Selenium, you have WebDriver.js, which is able to give you a JS interface for you to control Selenium. You can spin up many browsers. You can do a lot of things. Puppeteer is made on top of a headless CRUN, if I'm not mistaken. So basically what I like to do with end-to-end tests is check if actually your final user is getting what your final user should get. Basically go to features and interact with them as a final user would. Also, one of the things that I usually put in this category is storybook and docs. Because when you're developing component, if you're interacting with them yourself, like as external device, let's put it that way, as a human, I also think that qualifies as end-to-end tests. So for integration tests, it's a bit hard to sometimes separate them from end-to-end tests, but I think that the distinction that I usually make here is that unit tests are mostly used when I'm trying to get something done. So basically unit tests they're less about testing and they're more about doing small incremental steps to get somewhere. That's how I like to think about them. I have even written a blog post called TDD is not really about tests, because when you're doing TDD, you're not really trying to create these very huge tests to prevent lots of regressions or to catch many bugs. You're actually just trying to iterate and be sure of what you're doing. So I actually separate them. I think that this separation is a bit hard to do, but the way I try to separate them is whenever I run tests, I try to, if I'm using Enzyme to interact with the component as like a user would, like simulating events, like bubbling up events, and like interacting as if I were someone using a browser, even though I'm not using really Selenium or any of those tools, then I would put them in this category. So so I think also it's important to make distinctions between tools here. So between test runners, between assertions and mock tools. So Jest does a bit of everything. I really like to use Jest. And one of the things I usually do, which most people don't, is to combine Jest with Chai. So Chai, when there's an error in assertions, it throws an assertion error, which is like an interface which is very well described. So it's really easy for Jest to provide good diffs if you're using assertions with Chai, and they're also really easy to write. I think they're more flexible, so I quite like doing that. And for mocks, I think if you're using Sino, I don't think it makes much sense for you to, if you're using Jest, it doesn't make much sense for you to use Sino. But if you're using Mocha or Ava, I think it definitely makes sense to get rid of the indeterminism in your tests. So if you have like clocks, if you're dealing with dates or things like that, it's very important that you stub them out so you can isolate your variables, just like as if you're doing experiments, since tests are just really experiments, and make sure that they're reproducible, that you're going to get value out of them, that they're not just going to be flaky. And for integration tests, as I said, I usually use Enzyme. Many people use reg testing library, and both of those are built on top of JSDOM, which is just like fake implementation of the DOM. So basically, if I need to interact with any browser's API, what I usually do is I will stub those browser APIs, and I'll make sure they're being called. I'll make sure they're being called with the right things. They're being called the right number of times, and that kind of thing. And well, for unit tests, I've already made the distinction. And while the tools are really similar to integration tests, but I mean, I try to keep them more constrained. So if I have components, I will not really try to interact them and bubble up events and simulate events. I'll mostly call the functions directly or call methods in the functions directly. So if you're into test-driven development, I think this blog post is really nice. And it talks more about what I've said regarding test-driven development not being really about tests. And in regards to snapshot testing, I think also that sometimes many people will abandon other kinds of tests for doing snapshots because it's a lot easier. But I think snapshots do have their place, but they should not be used like all the time. And I think that is interesting to do snapshot testing when you have like a component in which you have to test, for example, if a button always renders, or if a button always renders a certain class, and things like that, which are very repetitive to do, and that you're really not much concerned with, or that you don't have much interaction with. And you can use snapshot testing for many things that are not just rendering components by leveraging that with serializer. So you can have, for example, snapshots for images. You can use snapshots in many testing libraries. And one of the very interesting things that Jest itself does is that it tests itself, it tests its outputs by running snapshots of its own console log. So basically, it captures standard output and standard error and the streams, and basically you get that into a snapshot and you compare that to, in the future, to those snapshots that you have recorded. So it's a very good way of doing end-to-end tests, not only in the front end, but also if you're developing a library or things like that. And well, that's pretty much it. I think I've been quite fast. But if you want to follow me on Twitter, I'm there at the Wizard Lucas, or on GitHub at Lucas F. Costa, and my website is lucasfcosta.com. And if you have any questions, or if you didn't like that I told you that math's not really science, please tweet at me.
Great. Thanks a lot. Cool, do you have any questions? Got one here at the front.
Why don't you like Cypress?
So, like, so I really like things that I have full control over. So, like, I really like using Selenium because, like, so for example, like if I have to test, if I have an application which has like many services, right? I have like many database instances running, and I need to test it like a real end user would. Right? I can simulate states on those databases. I can send packets through whatever interfaces I have. So I have full control over what I'm doing. So I really like that aspect. I mean, I haven't really used Cypress that much, but I like having the control over what I'm doing. So I think that's why I don't like it that much, but maybe I'm just not used to.
Yeah, well, I'm just asking because we're going to start to use it.
Mm-hmm.
We might start to use
I see.
But honestly, I don't know.
Yeah, no, I've heard great things about it. I haven't used it that much. I just really like the aspect of control. I even have friends which work at Cypress, and you know I know they're all really good. It's just that like I think for the things I usually do, I prefer to have full control over what I'm testing. It's more about that.
Okay. All right. Thank you very much.
Yeah. Thank you.
Cool. Thank you very much, Lucas. Great. So before we finish things, I just want to say a big thank you to all of our speakers and to News UK for letting us host the event tonight. So big thank you. Cool. So we want to know how you felt, how you found this evening. So please let us know how you found things today by using the hashtag #ReactLondon, all one word, in any of your social media posts tonight or whenever. So we actually host a variety of meetups, not just this one. Some focused on mobile development, some focused on designs, some in strategy. So if you are interested in kind of keeping up to date with what we're doing and the events we're putting on, being notified when tickets go live, etc., please feel free to sign up to our mailing list at our website, red-badger.com. We are also hiring for a bunch of developer roles at the moment. So yeah, if you are interested in that, you can go to red-badger.com/jobs, or you can pick up one of these on your way out, which are just on the table there with the rest of the other freebies that we brought up for you tonight. So this will just give you a little bit more information about us, what we do, and what we provide for our clients. So yeah, if you're interested, red-badger.com/jobs, or pick up yourselves one of these. So the bar's going to continue serving drinks for about another 20 minutes or so. So if you want to grab a couple more free drinks. If you do want to continue drinking, I'd recommend a very good pub downstairs called the Telephone Exchange. So yes, if you want to make a night of it, feel free to go there. And lastly, I just want to say a big thank you to you guys, and I look forward to seeing you at a future meetup. Thank you.